Spark Academy, and in this video we're going to be looking at upper and lower bounds. So any measurement we make is rounded to some degree of accuracy, so this could be to the nearest metre, centimetre, litre, any measurement, okay? So the degree of rounding gives the possible values of the measurements before rounding. These are known as upper and lower bounds, or sometimes we know them as limits of accuracy. So the Empire State Building is 443 metres, but obviously this isn't the exact value, they just rounded it so you haven't got to say a big long number. So the actual value, if it's been rounded to the nearest metre, it could be, obviously it can't be anywhere near 442, otherwise it would have rounded to that, same with 444, so it's got to be 442.5 or above, but only up to 443.49999 recurring. But it wouldn't look very neat, and if we're trying to do calculations with this, it can make it complicated. So what we would do is we'd actually round this to 443.5. But obviously if I rounded this to the nearest whole number, it would be, or to the nearest metre, it'd be 444, so that won't be correct. So how we get away with this is we write it as an inequality. So that means the height of the Empire State Building is 442.5 metres up to 443.5 metres. But notice there's not an equal sign here, so it's all the values up to but not including this. It does include this one, because that's fine, that would round up to the right number, but here we don't have an equal sign. So the Bugatti Veyron is 4.6 metres long, measured to the correct 1 decimal place. So the lowest it could be is 4.55. Now notice I put extra zeros on the end to help me work that out. And the highest it could be is up to but not including 4.65. So again, we'd write this as an inequality with an equals on the lower bound. So it's 4.55 including 4.55, but up to 4.65, but not including 4.65. So we're going to do some calculations now involving upper and lower bounds. So you can, obviously if you do an area or a volume calculator, there can be errors of measurements in this as well. So if your error starts off with your length, it's going to get even bigger when you get into your area or your volume. Okay, so this is why you have to be really accurate. If you're like a construction worker or an architect, you've got to be really careful with your calculations. So if a room is measured 6.4 by 4.3 metres, but this is to the nearest 1 decimal place, we're going to see what the actual lowest area can be and what the highest, because this would help people think, right, how much material do I actually need to buy just in case. So 6.4, the lowest it could be is 6.35, the highest it could be is 6.45. And again, even though this would actually round up to 6.5, we use this measurement instead of having to deal with recurring decimals. The lower bound for 4.3 would be 4.25, the upper would be 4.35. So the smallest area, we times the two smaller lengths together, so we do the 4.25 times the 6.35. So that would give me 26.9875 metres squared, or 26.99 metres squared to 2 decimal places. Then if I do the maximum area, so I've got the 6.45 and the 4.35, I get 28.0575 metres squared, or 28.06 metres squared to 2 decimals. So the smallest area I could have was 26.99, the biggest was 28.06, so quite a big difference really. Okay, so this is why we've got to be careful with our measurements. So going back to the Bugatti Veyron again, it can travel 100 metres to the nearest 10 metre in 4.4 seconds, but the 4.4 seconds is to the nearest 1 decimal, 800 metres is, like I said, to the nearest 10 metres. So we want to find the maximum speed. We'll start by finding the upper and lower bounds. So the lower bound would be 795. The highest it could be is 805. Okay, so one way to think about this, because it's to the nearest 10 metres, what you do, you halve it and take that off and add it on either side. Okay, then with the 4.4 seconds, because it's to the nearest 1 decimal place, think of it as in like powers of 10. So 1 decimal, you'd write that as 0.1. If I halve that, I get 0.05. So if I minus that, I get 4.35. If I add it on, I get 4.45. So if I want to calculate the speed, I do the distance divided by the time. I want the maximum speed. So the maximum speed is doing the greatest distance in the shortest time. So my greatest distance is 805, the shortest time is 4.35, because if you do the biggest divided by the smallest, it will give you the biggest answer. Okay, so if I do that, I get 185.0574 metres per second, or to round it nicely to one decimal place, 185.1 metres per second. So that's all for now, but if you have any further questions, feel free to ask in your lesson.